Thank you. Yeah. Good afternoon, everybody. It's truly a pleasure today talking at the Data Inch Bites. I hope everybody is having great time attending all the lectures and the presentation along with having the yum food. Oh God, I love food. Yeah, so in today's presentation, we are going to talk about how we serve a multi-platform data lake via Delta, Iceberg, Unity, and Glue. So it's essentially a database-less data engineering with no vendor lock-in platform.
Hang on, did you say database-less?
Yes, so there's no database involved.
I'm sure you guys are curious to know more, right?
Yes.
Nice.
Obviously, yes. So this is what we are going to talk through in our slides. But before we start diving deep into the presentation itself, here is something about us. Yeah. So along with me being a foodie, I'm also a staff data engineer at Block. And in my last 14 years of experience, I have worked with multiple banking clients like Bank of America, National Australia Bank, across multiple domains like wholesale, marketing. And I strongly believe that change is the spice of life, which drives my passion towards continuous learning and improvement in both personal and professional life. I have with me Amey, who, trust me, is a bigger foodie than me. Yes, he is the one who finished all the food outside.
Hi guys, it's a really pleasure to talking to you today and taking through our journey and the impact we have made in Block. So as Ankita said, I'm an avid foodie and I love sports as well. I've been lucky to work with industries like finance, digital marketplaces, aviation, and off late, buy now, pay later. I'm an avid learner and I want to use new technology to improve our way of working every time. So Ankita, without further ado, when I joined Block 2 years back, we started on inception of this new journey, right?
Yeah.
Do you want to take us through?
Do I remember? Oh yes, I do exactly what happened. Thanks to the soaked almonds that I eat every day morning. Yep. So, back in Feb 2022, we used to call our data platform Vega. So for context, our team loves stars. So whenever we keep any project names, we make it related to stars. So Vega is one of the brightest stars in the lunar constellation. So what we did in Vega, we ingested data from source systems, loaded them into landing area, which was Amazon Redshift and Amazon S3. Then we cleansed the data, transformed it, and provided it in a single layer, which was Amazon S3 in the Parquet format. And we exposed the data to the end users via AWS. But this particular implementation, it lacked the basic asset guarantees. So there was no atomicity, no consistency, no isolation, no durability. Oh my God. So how we resolved it is by persisting the data over to Redshift. So if we see here, we are storing the data in S3 and now in Redshift, and where end users used to access our data. But then, boom, in Feb 2022, Block acquired Afterpay. Now, Block is an ecosystem of ecosystem in which we build things together in order to achieve economic empowerment. And with the acquisition, more and more Block users wanted to access Afterpay data. Now this thing, it was not that easy and straightforward, but we wanted to unblock our Block users immediately. So we did it in 2 steps. The first one was to extend our existing Vega architecture to provide the data in Snowflake. And why we were able to do it so easily and quickly was because of our S3, which was the agnostic storage. So then, step 2 was optimizing delivery. So everybody would be wondering that though we were able to provide the data to Snowflake, why did we have to go with the optimization? Because with the acquisition, we started facing huge demand for scale. So we got 9-fold increase in our user base. Next was the demand for variety, which also increased. So Amey, you remember the RIS team, they approached us asking for us to provide the data in Databricks, and they were after timeliness.
Yeah, I definitely remember that. And other examples were finance team, whose priority was precision and accuracy. So they wanted data in Snowflake available as well.
Exactly. Right? So we had got multiple stakeholders with different requirements to tend to. And then as data platform team, we all know that the things, they keep changing really very quickly. Technologies, they come, they go. Vendors introduce new features. Even the vendors, they change sometimes. But we didn't want it to keep changing our platform based on these changing things that we didn't have any control on. So as far as possible, we made a decision that we are going to go open source. Now for implementing this step 2, optimizing the delivery, we had two options. Either we can expand our existing Vega platform by making it multi-cluster, but there were challenges with our existing platform itself. First one was, as I mentioned, we were replicating the data over and over again, once in S3, then in Redshift, and now in Snowflake. So it was not a cost-efficient architecture that we were following. Other thing was that for achieving asset guarantees, we had to fall back on a database. And the third thing that I would say is that one of the challenges that every engineer faces is the data quality implementation. So even we had only bespoke data quality implementation. They were not standardized across the pipeline. So the other option that we had now was going databaseless with a favor of interoperability. And this is the option that we went ahead with. Now, in order to implement this option, we had to re-architect our platform. And the new platform, we named it as Orion. So coming back to our team's love for stars, Orion is a constellation of the brightest stars. So Vega is just one bright star in the constellation, but this is a constellation of all the bright stars. So Amey, would you like to share how we planned Orion to be database?
Yeah, definitely. So let's go through why we came up with the term databaseless and what do we actually mean. And the clicker is not responding. Okay, so this is pretty standard pattern where we have source systems, we have landing. As Ankita mentioned, we already have data in S3. But with the new inception or the new take acquisition, we know that we have new set of evolved set of users, new technology points to touch upon. That means serving layers to touch upon, and if we go with the same approach that we have been so far, we'll end up creating multi-copy storage, as Ankita also touched upon. So what does this mean? So to achieve and serve reliable data using and serving with asset properties, we have to copy data into different databases. Although all these many platforms mention that you can scale up and scale down the compute, they need data to stay in their environment. So what option do we have? With evolving technologies, we found an option in serving data via single copy and multi-format storage. Now, what does that mean? We would using multi-format storage, which we'll get into in detail. These formats allow us to have asset property as a part of that, very close to the storage area. So the way the formats operate, the way they serve the logs, they're able to provide us consistency and accuracy, all the asset properties with the format itself. So how does that help? Now with this case, the feature of assetness is about to the compute engines that is used. So end user can come up with any compute engines of their side, on their side, and we are actually able to detach the compute and storage in true sense. So this was what we termed as databaseless. So we give more options to the user, and we also achieve the the asset properties that we aim for. Now, to achieve this, we obviously in every project have to have some very key principles that we have to derive from. So we have our key requirements available with us, key serving areas available with and new business users. How do we serve them? We want to definitely come up with agnostic storage, which is basically carried over from Vega, our old platform, and S3 is our natural choice, being an AWS shop. Asset compliance. This is one of the key principles we have been harping about a lot. So with our research, we found that Delta Lake is the format which suits us the best. We'll go into details of some of the key features we considered for the same. What does Delta Lake do? It gives the same multi-format or asset properties based on the format, not relying on the compute that we have. So compute can be pretty dynamic. For our engineering work, we have to come up with a catalog. Although Delta Lake can work with files as such, Catalog gives us abstraction of locations while moving tables and maintaining data. So for engineering purpose, we use AWS Glue. This allows us to cover a very key point Ankita mentioned about not being a vendor locking, in the sense we are logged in on AWS, but that's a cloud provider. Moving away from AWS is a different talk altogether. But at least we are not tied up on a platform provider. I don't want to name them, but yeah. So AWS, you achieved our target of having no vendor lock-in. We know we have users to be serving via Unity Catalog, Snowflake, and over recent times, we are able to use features like Delta Lake or Uniform, which we'll dive into as well. And that allowed us to serve data in Snowflake and Unity Catalog in a proper database-less way. Now, one of the key principles to move faster is that you don't have to check in and check out code every time you want to add a table. So we want to be metadata driven. It will have its phases, but with metadata, people can actually make updates in databases or using portals, and then we can generate DAGs automatically. We can onboard new tables in a quicker and much faster way. So every work that we do should be metadata driven. And one of the most important things, DQ gating. These are synchronous DQ checks which we want to put. Why did we highlight this separately? Well, we were in a new environment. We have more scaled up users, more end users, and obviously we want to make sure that they trust our data. So we want to call out this as a key engineering principle at every hop or transformation or ETL that we do. So let's now dive into the reasons, as I mentioned before, why we choose Delta Lake. Well, we need catalog. That was straightforward, and Iceberg Delta Lake covered that. Asset guarantees, as we mentioned, Iceberg and Data Lake are able to cover that for us. DML operations, we all know the pains to go through when we only work with Parquet files. Shallow cloning, this is a feature which will help us create copy of tables without actually copying the data. We'll discuss use case of using shallow clones further, but this was one of the key features that we were looking for. Time travel is a lot of times a boon, especially when we have some failures in DQ or ETL bugs, which allows us to take our tables to a time at the previous time or previous state. So this has been very handy for us practically as well. So definitely try to use that. Deletion vectors is cost efficient and a very much smarter way to manage DML operations and access them quicker or make them happen quicker. So Ankita, this talk is enough. Let's go through some implementation.
Yes. Let me talk you through the cool part of it now. So this is a high-level walkthrough of our Orion architecture. So we first ingest the data via the source systems and land it into a landing bucket. Then we transform it, massage it into a single format, which is a Delta Lake format. And then we split the data into sensitive and non-sensitive. So this process, we call it as classification. Now, why do we have to do the classification here is the question. So with this classification process, we make sure that we touch upon or resolve the issue of data access control at the grassroots level itself, instead of depending upon the presentation layer to do it. So we know that all the different platforms, they have the masking technologies or tagging and everything which is already available in the market. But we didn't want it to go with those vendor features. So this is linking back to our decision of going open source, so no vendor locking. So that's why we split the data in the first go itself in our layer. So that's the external layer. And after this, the users, they can actually access this data either via Unity Catalog or Glue Catalog or Snowflake. Now in this entire pipeline, we made sure that we have inline DQ quality gates at every stage, which is something that we are going to talk about in the later slides. Another thing that I want to mention in this slide is that when it comes to compute, we made sure that we use Databricks as a compute. Now again, why did we choose Databricks? Because of our choice of Delta Lake, as Amey explained in the previous slide. And another good thing was that Databricks was already in use in Block, and we had a dedicated platform support team for Databricks. So coming to the inline DQ gates. So doing data quality checks is one of the challenges that every data engineer faces today. And nobody wants to actually provide a non-trustworthy or a dirty data to the end users. So how we tried to curb it at our end was to put synchronous or inline DQ checks at each and every stage. So if a data quality check, it fails at one stage, the data should not proceed forward and corrupt the data that we expose to the end use. And in order to implement it, we use shallow clones. So now, what are shallow clones? Shallow clone is a clone or a copy of the data or a table without actually copying the data itself. So it just copies the metadata, not the data. It points to the original data. Now, why did we choose shallow clones in the first go? So Delta Lake has got inbuilt support for shallow clones. So it made it easy for us to use it. Second thing, it's cost efficient. Why? Because it does not make a copy of the entire data. It just copies the metadata. Next is, it helps us making sure that we do not commit the data if the data quality checks, they fail. And the third and the most important thing is it's open source. Again, linking it back to our decision of going no vendor lock-in. Because I very well know that there are other SaaS providers which provide the same functionality, but we wanted to be platform agnostic. Now, a little bit into the implementation of shallow clones itself. So we extract the incremental data and then start our DQ process, the inline DQ process. We make a clone of the target table and then write the incremental into the clone table. So I repeat, we don't write the incremental directly into the target. We write it to the clone table. And that is where, on the clone table, we perform our data quality checks. So currently, we are performing some uniqueness checks on the clone table, and then we also compare the row counts with the source tables. And this is where our DQ gates, they come into picture. So if the data quality checks, they fail, we close the gate. If they fail, we close the gate, and then we don't write it into the target. We just fail the pipeline. But if they succeed, we open the gates and then commit it into the target. Now, this entire pipeline, we have used Airflow, which was also present in Vega, because it was a highly scalable and highly available orchestrating environment which was present, and we just took the same thing, ported it over, and used it in Orion. So when it comes to the schedule itself, this is how the pipeline looks like. So we have got the internal layer where all the transformation, it happens via the different transformation tools like Delta Live Tables, DBT. Then we classify the data. So we split the data into sensitive and non-sensitive. And then we finally publish the data over to the presentation layer. Now, a little bit zooming into the classification and the publication layers. So we start splitting the columns into sensitive and non-sensitive area, depending upon the column metadata that is present in our central metadata repository. So we know from the metadata that this particular column is PII, put it in the sensitive area. This is non-PII, put it in the non-sensitive area. And here is where our DQ gates, they come into picture, the one that I explained using shallow clones. If the DQ checks, they succeed, we write it into this external S3 layer and expose it via Unity and Glue. Now the next challenge that comes is, how do we make Delta Lake appear in our Snowflake? How do we make them talk to each other? So with the evolution, we actually follow different patterns in order to publish the data over to Snowflake. So this was the first thing that we tried. We built a Snowflake Delta external table on top of our Delta Lake. And then we created a materialized view on top of the external table. But then with this feature, it had its limitations. So it supported only very limited feature of Delta Lake. And it also came in a way of exposing huge data sets on Snowflake. So then when we went with the option of Spark Connector. So this is a Snowflake Spark Connector, which just helps you read the data from Delta Lake and load it as is into Snowflake. Now, in both these implementations, if you see, we are actually persisting the data in Snowflake. So what we were doing in Vega, we are doing the same thing here as well. We are copying the data in S3, and the same data is also present in Snowflake. So then, in June 2024, Databricks, they made Uniform as GA, and Snowflake, they made Iceberg tables as GA, which is what paved our way towards the third pattern and a more efficient pattern, which is uniform Iceberg implementation. And in this implementation, we actually don't have to copy the data over to Snowflake. Now, this implementation is something that Amey is going to talk about more in the coming slide, but I also want to touch upon one really solid engineering principle that we followed in our implementation is the abstractions. So read abstractions and write abstractions, which helped us evolve really very quickly. So these patterns, they came one after the other, but we were very quickly able to plug them in. Yeah.
So our talk is going from level 100 to 200 to now 300. So what is uniform? Uniform is universal format for lakehouse interoperability, which we want to achieve. It offers seamless integration across different multi-formats that we talked about. And in the current state of uniform, it supports formats like Iceberg and Hudi from the Delta Lake log files that are already present on the table. It works seamlessly and extremely easy to set up. We'll go through that. Now, let's go through the flow, high-level flow of how it works. We have a Delta Lake table, and uniform is a table property over a Delta Lake table. So you basically onboard or enable a uniform property on an existing table, or you create from scratch. What it does is that it creates metadata for Apache Iceberg or Hudi, whatever you configure with, alongside the Delta log files. And what is the result? Now your end users can come up with any compute engines of their choice: Trino, Apache Spark, Snowflake, even BigQuery, which basically needs to implement the Iceberg specification to access our data. So in this case, these engines allow to directly use metadata path or the latest snapshot of Iceberg and access the latest state of the table. Or you can use the REST APIs as Unity Catalog can provide us. Now let's dive deep into how we actually implement it. So this is our tool set: Airflow for orchestration, Databricks at runtime, and Snowflake as well. We have Delta Lake table. The S3 looks like this. It has Delta logs alongside in the table itself. So everything, concurrency, everything is managed in this itself. We onboard data onto a Unity catalog. Now this is to serve our end users who want to access data over Unity catalog. This is very straightforward. But when we do that, we also enable uniform properties. Now, there are two options here. Either you can automatically create the metadata for other formats, or as we chose to do it, we actually call SQL commands at this stage to manually sync the metadata between Delta Lake and Iceberg. Why do we do that? Because we want a deterministic way to tell to the users that data is available till a certain point of time. You might as well make it just like materialize view or make it work like that. It can happen in the background and your data but it's not a seamless experience for end users because they have to know till what time my data is updated. Now we have to make this available in Snowflake. How do we do that? Snowflake provides database constructs to actually connect into S3 and creates an external Iceberg table which can actually use the metadata that is sitting in S3. And when it reads that metadata, it is up to those Snowflake engine to manage the asset properties if it has to write into, and which snapshots files to read from. But Snowflake is not using Unity Catalog here, right? Snowflake is using its internal catalog. So how does that internal catalog know which metadata is the latest one, or which manifest files or the snapshot is the latest one? So for that, Snowflake allows integration with Unity Catalog, which actually reads the latest snapshot or the latest pointer to the snapshot and updates its own catalog. The effect of this is that latest data is not now also available in Snowflake for consumption. Okay, how are we doing on time? Are we good? Okay, great. So yeah, let's go through benefits quickly. Obviously, cost saving. We are now storing data at one place. So there is single source of truth of data. We also achieve this principle. We can now leverage S3 cost saving features because data is in our S3 account. So based on our usage, we can park the data aside in cheaper storage as we want. operational benefits, low maintenance overhead. So this has been also very useful for us because now we have to run vacuum, optimize only on one engine or on one data lake, and the benefits flow in for other formats. There is no use of doing the same operations other databases. It gives choice of end users using variety of engine like Spark, Trino, any engines, as long as they implement specification of Iceberg, they are free to use that. And for comparison of performance, for our use case, we found that the external Iceberg tables in Snowflake were at par with internal tables, which was a very good thing. Now, all this is fine, technical. But how do we know that this platform is actually viable?
Are we going to show them the numbers now?
Exactly.
Oh, I'm excited.
So this is the most important thing, which makes sure we are making an impact and also saving our jobs. So cost in Vega. To process each GB of data in Vega, we were spending around 23 cents. And in Orion, the same was Jelly Bean jar. What is this?
Okay, so introducing the very first jelly bean counting competition in Data Inch Byte. So if you count the jelly beans, if you get the number in here, right, you get this entire jar of jelly beans. So if it's 23 cents here, can anybody guess how much it came in Orion?
7 cents.
Oh, that's very near.
That's very near.
So,
10 cents.
We got to go back.
7.6.
Yeah. So 7 cents?
8 cents.
Oh, that's correct.
That's it. We have to give
Please share your email ID. We'll copy paste the screenshot and give it to you. The jelly beans.
Yeah, so it was actually 8 cents, but the slide moved forward. Then it's actually automatically moving forward. Can we do something?
Yeah. Go for it.
Uh,
Sorry for the technical
yeah,
issues.
sorry. So it was actually 8 cents.
So we actually got a savings by 2.5 times.
Exactly. So that's massive achievement by the team. So really kudos to our team. So on other part, apart from that, how did we scale up? Because we have to keep up with the users as well. We're serving 3.5 petabytes of data. We now have around 80 DAGs, which are automatically generated, rendered, and running and serving around 400 plus tables. We have 6,000 plus users. This is actually around 9 times the users we were serving when we were in Afterpay. So that's a big scale up. So 35 self-business serving teams across the block ecosystem who are using Afterpay data. And this is as compared to few that we were doing in Afterpay world only. So that's the technical sharing we had till now, but we would really love to call upon our work of a great data engineering team. We really work well together. Our block IDA team, who we work very closely with, and this is at infrastructure at block level, unsplash.com for really good images that we could use here. We are opening for Q&A, and you can ask questions now or on the floor if you find us.